Do you see what I see? So we're going to take a closer look at optical illusions today, kind of look at how they work, why our eyes see what we see, and kind of why our eyes manipulate what we look at sometimes. So first, what is an optical illusion? Optical illusions are images that actually trick us into perceiving something differently than it actually exists. We can kind of look at this image over on the right side. You see, looks like it's going up and then the waterfall. Like it doesn't really make sense, but somehow our eyes are making it look right. It looks good. Optical illusions use color, light, and patterns to create images that can be deceiving or misleading to our brains. This information is gathered by the eye and processed by the brain. It creates a perception that in reality does not match the true image. So we're going to watch this quick video. So I think it's like a minute long. Just cool way to explain what they are. Let me know if you guys can't hear it or anything.
What is an optical illusion?
Optical illusions aren't just fun to look at. They're also really valuable tools for scientists to use to understand how your eyes and your brain help you make sense of the outside world. So in this example, there's two monsters in a hallway. And when you look at this picture, it sure looks like there's a big monster chasing a little monster. But actually, the two monsters are the same size. So if you take this image and you remove the background of that hallway, you can see that the two monsters are the same size. But it's even more clear if you just put them right next to each other. So you can see that the first monster and the second monster are actually exactly the same. Now, the reason that your brain thinks that the monster in the back of the hallway is bigger than the one in the front is because you've learned over time that things that are farther away look smaller. So if there's a monster in a picture that's really far away, but it's the same size as the one in the front, your brain says, well, that must be a really big monster.
So now we're going to kind of look into how exactly does this work. So we're going to do a tiny little thing on explaining how our eyes actually collect the light and create these images in our brain. So whenever we look at something, the brain interprets the object when the eyes see differently. So the rods and the cones are the optic receptors in the eyes. So that's going to be in this right picture back here. You see the rods and the cones in the back of the eye. Whenever light enters the eye through the lens, it actually hits the back of this eye, the rods and the cones. And what the eyes see is transformed into the brain as electric impulses, which the brain interprets. So that will go through the optic nerve, which connects to our brain. The brain tries to make sense of what the eyes see. And the optical illusions present something unusual to the brain. So something that might physically not make sense. So the rods are the receptors that help us see at night. So black and white colors mostly. And there's 10 million per eye. So that's a lot of rods in our eyes. And the cones, that's what helps us see color. So 5 million. Again, that's not that many, but you see here, the cones are responsible for us to see the light. And down here, you see this is the visual light wavelength. So the rods are the reason that we can see these colors on the rainbow. Okay, so now we're going to start looking at some actual illusions. If someone wants to go ahead and answer in the chat or speak up, what side of the rectangle is the darkest? But from this, once you're looking at it, the right one, right, Ajane? That's what it looks like, right? Because if you look at the rectangle does not look like it's the same color. It looks like a color gradient. But yes, so Aiden is actually correct. It is actually the same color. Or sorry, Daniel is correct. So, and you see why? Because the bar is actually the same color. Our eyes are perceiving the color differently depending on the color of the background or the foreground. So this is actually an illusion that our eyes create to make sense of objects. So it says here, you get rid of the background, it's the exact same color. It's very cool when you look at things like in life. All right, this next one, this is actually one of my favorites growing up. The first time I ever took psychology, we looked at this and I thought this is so interesting. I want you guys to go ahead and look at this and tell me, what do you see? Do you see an old woman or do you see a young woman? To me, I see an old woman. Angelica sees both. Susan has seen this before. Yes, it's a very popular illusion, but it can really be, sometimes it's really hard for people to see both. Does anyone here only see one? Sure. Does someone want to explain where they see the old person and where they can find the young person in this image? I see Daniel sees the elderly person. Yes, Ajane, the hair is gray looking. That's right. You guys ready to see the answer? The old woman nose is the neck of the young woman. Yes, that's absolutely correct, Susan. So yeah, it is actually both. The mother-in-law's nose is the wife's neckline, and the wife's necklace is the mother-in-law's mouth. This actually was created in 1915. Back when this came out, it was almost impossible to see both the wife and the mother-in-law at the same time. And also research tells us that usually people tend to see faces of people from similar ages. So younger people, such as yourselves, will usually be able to see the wife first before the old woman. And down here it says, yeah, if you can't see the mother-in-law, focus on the wife's right ear. Yeah, you see, right? So the old lady's eye would be the young wife's ear. And it kind of looks like she's like looking away from the camera. Yeah, really cool stuff. So next up, we're going to be looking at kind of creepy picture. So I guess beware for that if you get kind of scared. I'm so sorry. So what I'm going to ask you guys to do for this one is I want you to stare at the dot that is on this woman's nose and stare at it for at least 15 seconds. Try not to look anywhere else. Just really focus on that dot for 15 seconds. And once you're done, I want you to look over at the blank space and start blinking rapidly. And then let me know what you guys see once that happens. I'm gonna go ahead and do it as well. And make sure when you blink, you're blinking pretty fast because that's actually when you're gonna see the image. Yeah, exactly, Linda. What you're supposed to see is kind of the exact opposite of this image. So you're gonna see a woman, but she looks pretty normal. I mean, she looks like an everyday picture, you and me, but it only lasts for a few seconds. Yeah, the image is pretty creepy. But I think it's so cool, like the end image that you end up seeing. So before we move on, and I kind of explain how that was possible, do you guys have any maybe explanations of why you think you're able to see a color image after you stare at the black and white image for so long? Daniel, no, I'm not casting magic spells, not you. But yeah, definitely it's a Halloween pick. Yeah, why do you think this happens? You guys can either write in the chat or speak up. Either one. I'll wait a few more seconds. Yeah, so you're right. It actually does have to do with the rods and the cones in the eye. So basically, this happens because when you stare at something for a long time, let's say in this case, it'd be this woman's face looking at her nose, an after image comes about. So that just means when you stare at something for a really long time, those receptors in the back of your eye, they get tired after staring at something for a long time. So that's why that image kind of gets printed into the back of your eye. In some cases, you're going to see the colors exactly as they were in the original image. So that's called a positive image. But in this case, you're going to see the opposing colors. So once those colors get tired, then your brain is going to interpret that as maybe it's on the opposite side of the color spectrum. So that's why instead of seeing these dark colors, you see those light browns and things. Because if you look at a color wheel, those are actually on the opposite side. So this is an example of a negative afterimage. We're going to talk a bit more about that with another illusion coming up soon. Yeah, it's really crazy stuff how our brain works and how it makes stuff like that happen. Okay, so this one's a bit more complicated, I would say. Not necessarily, but it is definitely a bit weird. This is called the Hermann grid illusion. I want you guys to look at this and kind of see if you can count how many black dots you see. Do you guys see any black dots in this image? What people usually see is they kind of see little black dots like in the intersections of the lines between the boxes. Does anyone else see that as well? Whenever you look around? Cool. Okay, so, oh, hi, Tracy. So yeah, we're gonna talk about a bit how this can happen and why our eyes see this. Because if you stare really hard at the actual center of these intersections of the boxes, there isn't actually a dot, but it tends to look at it the more you look around those boxes. So yeah, the answer is there actually aren't none. This is actually an illusion that your brain comes up with. So there's only black blocks in the white space between those black boxes. This actually happens because of high contrast, which just means the really bright lines between the boxes and then the really dark boxes in this image. They're going to give the illusion of gray or black dots at these intersections. So yeah, if you focus on that where the dot would actually be, you see there's actually nothing there at all. So yeah, it's really crazy. It's one of my favorite illusions. Okay, and now we're going to look at this one called Lilac Chaser. I want everyone to stare at the plus sign for, let's say, about 10 to 15 seconds. And let me know what you see that starts changing throughout the image, the more you stare at it. Go ahead and write it in the chat whenever you see something weird happen. Ajay sees the dots moving. Tracy sees the dots disappearing. Angelica sees that the dots seem to be blinking or moving. Hogwarts, yeah. Susan sees, yeah. So actually, if you stare at it for long enough, you'll actually notice that the dot that seems to be moving around the circle actually ends up turning green. And yeah, so this is some really freaky illusion that I love looking at. One, because I love this lilac color, but how the color can change just from staring at an image. So cool. So we're going to talk a bit about how that can work. Here, the lilac GC illusion is an example of what is known as apparent movement. So when you see something in one spot and then again in a slightly different spot, you tend to perceive movement. An example of this would be looking at neon signs, maybe if you go to a restaurant. Up here, you can see it kind of in the corner. It looks like this lady is kicking her leg up, but in actuality, the lights are just turning off and on. So that's something really cool. So yeah, it's giving the illusion that it's actually moving. So in the last image, in this image, you see it looks like it's moving around, although it's really just what's happening here is the light just turning off. And it happens in a way that it makes it look like it's circling around. The next thing that is going to happen, we kind of already talked about this last time in one of the past illusions, in the crazy lady one. So this is what it's going to be called an after image result. So the color actually turns from purple to green because, as you see here on this color wheel, that lilac color is the exact opposite on the color wheel will actually become a green. So yeah, once you stare at that color for long enough, your eye kind of gets tired. Those cones and those rods in the back of your eye, they get tired for looking at it for so long. So then your brain will change that and create it and make it look green. Yeah, that's going to be the negative after image because it is, again, like kind of the opposite of what the original color was. And so now I want us to kind of create our own illusions. So these are just some examples of some that I found online. So creating a box like on a paper that looks like it's really deep. This heart looks like it's jumping out of the page. And then this cave and this field, it looks like, you know, it's like it looks like it's going to keep going. So these are all just some examples of illusions. So if you guys can go ahead and grab that piece of paper and that pen and marker, we're going to go ahead and take some time and try to create one for ourselves. I will be playing a video. So if you don't really have an idea of what you can make, you can just follow along with that video with me because I will be creating the step-by-step one in that video. And yeah, and then I would love to see how they turn up at the end. So again, feel free to make anything you'd like, but I will be playing this video just in case if no one can really find anything to make. So in this video, we're going to be looking at this picture on the left. So how to make a 3D hole. All right, so we'll go ahead and hit play and then you guys follow along or just create whatever you like. And then once it's over, we'll take a few minutes to finish up anything. And if possible, please turn on your screens and then we can talk about them. Okay, so I'll give you guys a few more minutes to finish it up. So who here decided to draw that box, and who decided to make something else move? I'm still shading. Okay, so Susan and Linda drew the box. So did I. Yeah, it could be actually black hole to another dimension. Kind of what it does look like, doesn't it? Okay, so I'll go ahead and stop sharing. I can look at you guys. And whenever you guys are ready, please hold up your drawing. And I'm very curious to see what it looks like. So this is mine. Kind of a little funky shape, but I think it did the job. Oh, Trissy, sorry, not at all. Oh my God, Ajane, yours looks amazing. It really does look like it's jumping off the page. Linda's looks awesome.
I'm a little embarrassed. Mine doesn't look very good. I'll show you. Okay, bad. I had the wrong type of marker.
Oh my gosh. No, it looks good. I mean, it gives the illusion. That's all that matters. Yeah. What I ended up doing too, I don't know if the video showed it, but I try to shade in the bottom part a bit more than the top. So it kind of gives the illusion that it's deeper. So maybe if I hold it like this, counts. I don't know. What do you guys think? Don't worry about that, Angelica. As long as you can, we're so happy that you were able to join and just hang out with us in general. So no worries at all. Yeah. Anyone else still working on theirs? I'm actually very excited to see what you guys come up with. And of course, no one's gonna judge here. I'm definitely not an art major anyway, so it's all for the fun of it. Yeah, Linda, that's actually very true. Let me actually see if I can pull up an image like that as well to show you guys, because that is actually a really cool illusion as well. found one. I'm gonna go ahead and share my screen to show you guys. We can kind of talk a bit more about this one too. Okay, so we're gonna look at this illusion now too. So you see here are two kind of flower-shaped objects. Which orange circle looks bigger to you guys, the left one or the right one? Ajane says the right one looks bigger. Right. And again, this is kind of connected to some of the other ones we just looked at. Actually looking at if we remember the video where like the monsters running down the hill, context is everything. The background means everything. So if you actually take away those circles around the orange object, you'll see that those objects are actually the exact same size. But because of the circles that we put around them, it actually can make the circle look bigger or smaller. The way of interpreting it is very different. So the one on the left, the circles are huge, so it makes the orange circle look a lot smaller. And the one on the right, the circles are smaller than the actual image in the middle. It makes it look bigger. Oh my gosh, Daniel, that is actually an amazing idea. That'd be really cool. And I'm sure it would freak some students out as well. So yeah, illusions exist everywhere in life. Whenever we study painting, whenever we look at a drawing, like the one here on the right, you'll see that this is, you need to remember, this is a 2D paper. This image is not actually go deep in there, but because of the drawings and the shadows and the way that you draw the outsides of the caves going in, that actually makes it seem as if it is actually 3D and it is a very deep cave. So yeah, illusions, this is just how our brain kind of makes sense of things like this. Very cool stuff. That's all I have for you guys, but I'm more than happy if you guys are willing to go in and you want to talk more in depth about certain illusions that I showed you today, or you have any more ideas for how you can make illusions cool on campus, like Dan said. Yeah, please feel free to write in the chat or, just unmute and speak up, anything at all.
Ashane, I was wondering if with some of the coding things that are you are learning about, if it's possible maybe to create some optical illusions for the computer, images for the computer using coding.
I'm pretty sure you can do that with the coding, but I don't really know how to because I've never did it before.
Yeah. Well, maybe as you increase your skills, you'll be able to do some of that. Yeah.
Yes.
So anyone have any questions for Paola or any cool ideas that you would like to share with everyone? All right. Well, I think we are done for today. And thank you so much, Paola. This was really fun and interesting. And it sure, for me, was a nice break from all the things that I was doing. And I think everyone had fun with that. And I think Dan is in another dimension at this point. Thank you.
It was a lot of fun. Thank you guys for taking time to Saturday.
All right. Take care, everyone.
Thanks. Bye-bye.
Bye.
Bye, Linda. Bye, Ashane. All right. Good job, Paola. Good job.
That went a little faster than I thought it would, but I think